Okay, continuing on today with our playlist on the principles of the definite integral. We have here the integral from 0 to 2a of f of x dx equals 0, given this condition over here to the right, that if we have f of x plus a is equal to minus f of x. I came across this one recently doing an integral from the MIT integration bee, and I thought it was pretty useful and interesting, so I just wanted to go over how this works. So to get started with this, I'm going to just take this first integral and we're going to split it up on the bound. So first integral is going to go from 0 to a. But then for the second integral, this is going all the way to 2a, so we can write this as a to 2a f of x dx. But then what I want to do on this is I just want to focus on this second integral. And what I want is, let's adjust these bounds. I want to get the bounds to be the same as what we have over here. So what I can do is if I just subtracted an a from each of these, then we're back to this. And I can do that with a u substitution. So for my u, let's just do x minus a. Solving for x, we have x equal to u plus a. Then let's take a derivative here. So for the dx value, this is going to just be du. So then coming over here with this, just making our u substitution on this, plugging into a here, we get a for the upper bound. Then plugging in a, we're going to have 0 for this lower bound here. Then for f of x, we're going to use this value right here. So this is going to become f of u plus a. And then dx is just going to become du. So now we have our bounds back where they were here, and we're going to want to add these two together. So let's get everything in the same variable. What I can do is, because it's a definite integral, I can do a variable change, and we'll change everything back to x. So I can write this as f of x plus a dx. But then with this here, let's just use this principle. This is our given that we were given initially, that f of x plus a is the same thing as minus f of x. So I can actually rewrite this. And now this is going to become minus f of x. But what I can do, I can actually bring the minus out front of the integral like this. But now I can take this and we can plug this back into our second integral in order to finish this off. But now that we have this plugged back in, we see that our second integral here, this is actually exactly the same thing as our first integral. So subtracting the second from the first, we just get our solution to this thing of just 0. Okay, there you have it. Just a quick look at this principle of definite integrals. Thanks everyone for watching. Have a good day.